All right, everyone. Let's talk about some solutions. Not problems, but solutions. Oh man, I think I made this joke 2 or 3 times in class today and I got no reaction in class, but here we are trying it again. I'll be here all week, folks. So this problem was from class Thursday, April 22nd, and as promised, I'm putting together a quick video to help you out on calculating molar concentrations for solutions. Firstly, I want to say if you're feeling a little bit confused, I do not want you to freak out. It is okay. That just means that you need to practice. I think we're all starting to see stoichiometry just requires repetition and practice. You are all very, very capable of mastering this unit. So let's get some practice. All right. Starting with our problem here, I'm aware that for G block, this says 0.75 decimeters cubed. You can change it if you want, or you can just do decimeters cubed. I'm going to show you the full conversion starting with centimeters cubed. So whatever you're more comfortable with. So I prepared a solution of 750 cubic centimeters of sodium hydroxide in the lab with 1.5 molar, or mole per decimeter cubed, concentration. How many grams of sodium hydroxide pellets did I need to add? So when we made the solution in our lab, we had our volumetric flask. I weighed out some amount of sodium hydroxide pellets. This is a weigh boat that I'm drawing. And sodium hydroxide pellets. I weighed out some amount. I added them to my volumetric flask. I then added deionized water, not distilled water, but deionized water up to volume 750 cubic centimeters. We can see here the lab steps. We need to mass the sodium hydroxide with an analytical or electronic balance. We needed to add the sodium hydroxide to a volumetric flask. I then add a little bit of water. I dissolve my solute in that small amount of water. I stir with a glass stirring rod, and then I carefully fill up to the volume that I wanted with the meniscus. I should also be using a funnel to do that. You are required for knowing this lab technique. It is part of the core curriculum, even though you're not being tested on paper 3 this year. So make sure you let me know what questions you have about that. I suspect the bigger question is going to be about doing this math. So let's get into what this math should look like. Again, 750 cubic centimeters. Here's my concentration. How many grams of sodium hydroxide did I need to add? So, like all problems, all I need to do is convert between units. This is a little tricky because I have 2 numbers now in my problem. So maybe I'm a little bit unsure of where to start. So let's take a look at what this should look like. Remember, for all of these problems, every single one of these problems, we start with the amount given. Any kind of calculation problem, I'm always starting with the amount given. I have 2 numbers here. I have a volume. 750 cubic centimeters is a volume. Remember, cubic centimeters are the same as mils, milliliters. Decimeter cubed is the same as liters. So I have about 3/4 of a liter here, or exactly 3/4 of a liter. And I have a concentration. Well, if I know that I need to start with an amount given, the only amount I have is a volume. So I'm starting in cubic centimeters, and I need to get into grams. That's the unit that it's looking for. It's asking how many grams, so I need to find grams. So now this is when I ask myself, what conversion factors do I have here that I'm going to need? Well, they give me one of my conversion factors. So if they're giving me a conversion factor, this is definitely one that I'm going to have to use. The molar concentration. concentration, which in this case is 1.5 moles per, let me make this super clear, 1.5 moles per decimeter cubed. All right, so they gave me a conversion factor, so I know that's one of the important ones I'll need. I see I'm starting in cubic centimeters, and eventually to use molarity, I'm going to need decimeters cubed. Interesting. Cubic centimeters, dm cubed. What's going on there? Well, I know I'll have to convert from one of those to the other. So 100 cubic centimeters is 1 decimeter cubed, 1 dm cubed. Okay, so I can track this along. I'm going to start in centimeters cubed, move to dm cubed. Once I'm in dm cubed, I'll be able to come down here, go to moles. I see that once I use molar concentration, I'll end up in moles, and I need to be in grams. How do I switch from moles to grams? Molar mass. So, molar mass, how do I find the molar mass? Excellent question. Let's take a look at what that should look like. I have NaOH. I need to look up the relative atomic masses in the periodic table. I'm going to use the data booklet periodic table, not a different periodic table. So Na is 22.99. Oxygen is 16. Hydrogen is 1.01. Not 10. And if we add them up, if I added everything correctly, we should get 40. The units for molar mass? Hopefully you're telling yourself grams per mole. So molar mass, 40 grams per mole. All right, so let's use these conversion factors to find a value here. Starting value, the starting amount I have is 750 cubic centimeters of NaOH aqueous. That's the symbol for a solution. So I have 750 cubic centimeters of aqueous solution. Awesome. If I have cubic centimeters of NaOH as my starting unit, well, in my next conversion factor, I better have that same unit, cubic centimeters of NaOH aqueous. All right, so I have used this unit here. I see that cubic centimeters, the conversion factor I have is decimeters, so let's throw decimeters cubed. And again, decimeters of NaOH aqueous. All right, so if I have decimeters of NaOH aqueous on top, then on the bottom in my next unit, the same thing, so that they'll cancel. Decimeters, moles. Why did I just put moles? Well, because I see in my next conversion factor of decimeters cubed, and I'm going to translate those to moles. All right, if I have moles in the top of my conversion factor, in the next conversion factor, I've used my volume concentrations, my cm cubed to dm cubed, my volume. I've used my molar concentrations from dm cubed to moles, and now it's time for my molar mass. Now that I'm in moles, my last step is to get into grams. And so, before I've even added any numbers, I see that my units will cancel. Cubic centimeters, great. Decimeter cubed, great. Moles with moles, great. So now my only unit remaining is grams. That's good because I want it to end in grams. All right, let's put in the numbers so that we can do our math here. So this conversion factor volume, how do these volumes relate? Well, in every 1 dm cubed, there's 1,000 centimeters cubed. For my next conversion factor, in this solution, for every 1.5 moles of NaOH, I have 1 dm cubed, 1 liter of solution. And then my molar mass. For every 40 grams, I have 1 mole.